Okay, great.
I'm going to throw the microphone now.
Okay, more mics, more fun. So my name's Matt Ray. I'm a senior technical evangelist with Opscode. We're the company behind the open source project Chef. So today I'm going to be talking about Chef, Chef and OpenStack, and deploying applications on top of OpenStack with Chef. So Chef is an automation platform. It's for developers and engineers to continuously define, build, and manage their infrastructure. It works together with recipes and cookbooks that describe we're going to talk about this more as we go, but first I just want to talk about Chef by the numbers. You know, we're quite a successful open source project. We were launched January of 2009. We broke 1 million downloads, I think sometime last month. Those are the ones that we're even tracking. We have over 700 individuals outside of Opscode who have signed a contribution license agreement allowing them to contribute code to the project. And so a fairly large percentage of those people have patches inside of Chef. You know, this is not just Opscode. And there are 130 companies that have signed that same license, letting them contribute their code under an Apache license. So Chef is Apache 2 license, which means you can embed it in your products, you can build a business around it, you can do whatever you want. That's pretty much the beauty of the Apache license. The goal is usage, not control. And by our count, there's at least 15,000 organizations out there using open source, and we've got over 450 cookbooks that community members dive into what all those things mean, but those are just some numbers to get you started. First, let's just talk about the problem state. Okay? So let's say you're, is there a question or? Okay. So let's look at the problem state. So you've got a small application. You're going to deploy. You know, you've got a little startup. You're deploying an app, and things are starting to go well. You've seen a little bit of traffic, so maybe it's time to segment out your infrastructure. You're going to have you move your database to another machine. Wow, the refresh is a little bit on the slow side. And now I'm going to slide. And, you know, traffic kind of picks up. The database turns out to be a bottleneck for your infrastructure. So you're going to bring up another database box. And then, you know, load is picking up for the website. A lot of people coming to visit your application. You're going to bring up a few more application servers. Eventually, you're going to need a load balancer in front of those, and I can see that it is not refreshing my slide. It's 3 behind. To enable you to work with just about anything. Yeah, some system administrators say, "Whoa, I'm not a programmer. I don't want to learn a programming language." You're already using programming language. You're using things like Bash or Shell or Perl or Apache 2 Conf, things that have inputs, they have outputs, they do things when you tell them to. That's a programming language. You know, whether it's something not very useful like an Apache 2 Conf or something really powerful like Ruby. And so what this allows us to do is have variables, for loops, use a much more concise for declaring what we want our infrastructure to do. And since we're using Ruby, we have the power to bring in any libraries that we may need to interact with. So perhaps you need to care about some external service or some web app or something somewhere that is not on that box. You can use, chances are very good that there's already a Ruby library for dealing with. And that's why we like Ruby. So with Ruby, you're going to be writing recipes. Now, a recipe is just a collection of resources. Your resources might be simple stuff. It might be, package Apache 2 and template Apache 2 Conf. And a recipe is just a list of the order that you want these resources applied in. And it may be fairly simple, and sometimes it's not. It depends what you're trying to do. These recipes are contained within cookbooks. Now, cookbook is just a package that contains how to deploy a particular piece of infrastructure, whether it's an application or a service. It could be something simple like ACP. It could be something complex like Nova. But a cookbook contains the pieces that you need to get it to work: the recipes, the templates, static files, anything like that. And what this gives you is reuse and modularity. And based on these patterns of reuse and sharing, people are using the communityopscode.com site to share these cookbooks. And so there are lots of examples out there. So if rather than have to go and write your own cookbooks and recipes for deploying a particular application, chances are very good someone's already done it. There's already really good cookbooks for, I think I mentioned 450 applications. There are more all the time, and those are just the ones on the community side. So once you have your recipe, one of the really powerful things about Chef is the fact that we use search. So because the Chef server is not telling each node what to do, instead it's saying, here's your run list, here's what you're supposed to do. When those nodes run, they're going to push up any information about themselves up to the Chef server. And the Chef server is going to expose that for search. And what this allows you to do is search for other nodes, to find other machines that you're dealing with, whether it's IP addresses or host names or port numbers, other machines running applications similar to you, whether you're building up a MySQL cluster or a load balancer. You can use search to tie these things together automatically. So when we talk about evolving infrastructure, we're going to use search to help us cope with that. So an example of that is passing results. So this is a recipe for HA proxy. It's a software load balancer. We see we're calling search. We're looking for all the web servers, everybody with the role of web server. And we're going to take that, store it in our pool members variable, and we're going to pass that into our HA proxy config. This is the template, and so we're going to pass in the list of everyone who is a web server. We're going to pass that to HA proxy config, and then it's going to get written out as the template. So let's go to render. If you're familiar with HA proxy config, this is what it looks like, only we have a little bit of Ruby in here that just iterates over. So what this means is as the machines behind the load balancer change, the template gets rewritten, the service gets restarted, and you're automatically able to handle machines coming and going behind your load balancer. So as your infrastructure starts to scale up or scale down, you dynamically update this infrastructure. And so what that allows you to do is when you have an application that's fairly complex, like this, will we render? When you have this complex application and you make one small change, the updates are automatic. And just that one change, 12 resource changes just by adding one node. All the things that you have to touch, the load balancer, Nagios, Graphite, Memcache, Postgres, all those things get touched just by adding an application server. Doing that by hand is, a non-trivial problem. And so with Chef, you can build anything, whether it's simple internal applications, external applications, SaaSes, infrastructure as a service, PaaSes, Hadoop clusters, workstations, storage, whatever, you name it. Chef is probably already building it somewhere. And we make it easy to manage things. Your services automatically get reconfigured based on search results, on changing infrastructure. We have support for Linux, Windows, Unixes, BSDs, just about everything. Load balancers with APIs, load balance, software load balancers, those are supported. Metrics collection systems, whether it's Nagios or Munin or Xenos or any other monitoring system. Those things are all easy to manage, and migrating between clouds becomes really trivial. And so that brings us into OpenStack. Deploying and managing OpenStack is nothing. Hopefully, this isn't new news to you. It is the newbie track, but the OpenStack is still a fairly complex beast, and obviously, I'm here to tell you that Chef is going to make it easier. So there are a lot of cookbooks around managing OpenStack with Chef. Originally I had some, or Bear and Cactus, way back when. Those have been deprecated, but those were the source for the cookbooks used by Crowbar. Those were the source for those used by Mercado Libre, the number 8 retailer in the world. Those are the cookbooks used by, they were the source for HP Cloud Services, a very large public IIS about to, that's currently in beta. These are Apache 2 licensed, a lot of documentation around them up on GitHub. They are deprecated because they're out of date. Dell took those cookbooks, and we've heard a lot of good things about Crowbar. So Crowbar, I probably don't need to dive into it too much, but those same cookbooks are used by Crowbar under Apache 2 license. Lots of folks working on them. We've got a mailing list, Skype. We've got meetups like this. Those are all up on GitHub as well. Rackspace Cloud Builders, DreamHost, and Opscode internally are using another set of cookbooks that are facing a wide variety of deployments as well. There's an IRC channel, a mailing list is about to be formed, and these cookbooks are all out there as well. Tristack.org is a volunteer-driven OpenStack test deployment site. If you want to go and log into OpenStack, see what it's like, kick the tires, Tristack.org is giving out free accounts. This is set up by volunteers from NTT, HP, and lots of other places. And they're running on Zen and Postgres, which is a little different from most of the other OpenStack deployments we've talked about. Their cookbooks are also open source and Apache licensed and up on GitHub. And so what this brings us to is Opscode's roadmap for OpenStack. With all these different people teaming with Chef and deploying OpenStack, there's been a lot of interest in coming together with a centralized reference architecture. And so we're currently building that reference architecture by talking to all the different people that I just mentioned, Rackspace and Dell, DreamHost, and everyone else about, how are you using these cookbooks? What can we bring together to make a reference architecture? Opscode's not going to be an OpenStack deployer, but we are going to have cookbooks out there for people to run these things. There will be tutorials, a quick start tutorial about how to bring this up probably within the next month. And the documentation I previously mentioned is going to get refreshed as well. And there is a tremendous amount of interest around. Everyone wants to collaborate. OpenStack is really about the idea of collaboration and competition at the same time. It's people who, are competing, but they don't want to, do the same things over and over again. And how you deploy OpenStack should not be your secret sauce. And so this OpenStack reference architecture will be up on GitHub in Opscode's account, and will be supported on ticketsopscode.com. Kind of interesting stuff. But what's important is how we deploy OpenStack changes with scale. And luckily we have Chef to tie it all together. So as things change, as we replace different components, as we scale up, the cookbooks and Chef will be able to handle it. And by documenting this, sharing it publicly, and putting it out under an Apache 2 license, we can make this available to everyone. And there's going to be a lot of really great collaboration around it. So that's Chef and OpenStack. That's how we deploy OpenStack. But once you're using Chef, there's a really powerful tool called Knife. Now, Knife is our command line tool. It is essentially an API tool. It talks to different APIs, and it is a Swiss Army knife of API. So it talks to the Chef server API. So I can manage the nodes that Chef is managing. So I can say, hey, give me a list of all the nodes, update the run list on this one, delete that one, change how it works. But it also talks to a cloud API. So with Knife OpenStack, I can actually talk to the OpenStack API that I'm running, whether it's a site like Tristack or an OpenStack deployment from Crowbar. Knife OpenStack can talk to it and allow me to do things like list the flavors, list the images, what servers are there, let me delete that, let me create new ones. Flavor list, very simple. I can see a list of all the machines that are currently available, linked by their ID, their size, and the names. I can get an image list of everything that's on the box. Sometimes it's short, sometimes it's long. But knowing the flavors and the images, I can go and, from the command line, create new servers. I don't have to go into Horizon, the dashboard, and click around to create new instances. I can actually go and say, knife OpenStack server create, a flavor 1 and image 13 with a tri-stack key pair, and build a Tomcat stack of my application on this box, unattended. There's no manual steps here. I can go and fire up new Tomcat stacks on top of OpenStack, and I don't have to use a UI. I don't have to click anything, and that becomes really powerful as you need to deploy larger and larger stacks, as you need to have applications that talk to each other. Bringing up OpenStack is really powerful, but bringing up applications on top of OpenStack is what makes it useful. And so when we use knife OpenStack, these applications show up in the dashboard. So, that obviously is still going to keep working. And so we see our nodes get listed, and we can SSH into the box just as any other box. It's just an Ubuntu box, nothing super fancy there. And so knife OpenStack is currently under a lot of testing for ethics. And it works if you're not using floating IP. Hopefully I'll have floating IP support done in the next day or two. But everything else is working. Listing servers, listing flavors and images, creating servers, and automatically bootstrapping them and installing Chef on them, and then installing a software stack on top of them, with no second step. It's just a single command to create it. Knife OpenStack is supported by Opscode, so we have you can go and open tickets, and it is all open source. So if you have patches that you want to submit, I'm happy to work with you. And that's knife OpenStack. But really the important thing about knife OpenStack is it's part of a suite of tools with Chef. We have plugins for just about every cloud provider out there, and whether it's EC2 or Rackspace or HP, or name just about any other public infrastructure as a service, chances are very good that there's already a knife plugin. So if you're running on a cloud provider and there's some reason you need to move, you're not particularly happy, pricing changed, what have you, Chef makes it easy to make your infrastructure portable, so you can take it to new data centers, to take it to different clouds, and that's really, really useful. So that's all I have. That is a kind of a lightning introduction to Chef and Chef and OpenStack, but I hope you enjoyed it.
Thank you. Any questions on the online chat or the rooms? One question here is, what's the difference between private Chef and open source Chef?
So there are actually 3 flavors of the Chef server. Chef is an open source project, Apache C licensed, and so there is a open source Chef server that we run a hosted version of it called Hosted Chef. So if you go to Opscode.com, you can see that there. It's kind of like running email. Back in the day, you probably ran your own email servers, but I reckon a lot of folks today are probably using a hosted email provider. Someone else can run your email cheaper, faster, and better than you can. And so that's what Hosted Chef is. There are a few additional features related to multi-tenancy and role-based access controls, but they are API compatible with the exact same API and allow the same code base. We have been rewriting parts of Hosted Chef for performance, and we'll be open sourcing all those performance enhancements in the next major release of Chef. And so private Chef is the same code base as Hosted Chef installed behind your firewall and supported by Opscode. So it's kind of the classic open source business. You have an open source you have an open source product, and then you have a commercial version that you support. And so that's private Chef. And exactly API compatible, so you can go back and forth between hosted and open source. And we give out free accounts on Hosted Chef so people can get familiar with Chef without having to run your own Chef server, which is a fairly complex application by itself.
Thank you. Any other questions?